Hello, dear listeners, and welcome back to the AI Novice podcast. I'm thrilled to bring you another episode in our educational series on the foundational concepts of artificial intelligence. Today, we're diving deep into computer vision. Ever pondered how machines see the world around them or how they interpret images just like, or sometimes even better than, the human eye? Well, you're in for a treat. This episode promises to shed light on these questions and more. If you've been journeying with us through this series and loving the insights, don't forget to hit that subscribe button and share this podcast with fellow AI enthusiasts. Let's embark on this visual journey and discover how machines perceive the world. Let's kick things off by unraveling the mystery behind computer vision. At its core, computer vision is like giving machines a set of eyes, but it's not just about seeing, it's about understanding. Just as our brains process the images our eyes see, computer vision enables machines to interpret visual data, be it images, videos, or even live camera feeds. It's a blend of capturing visual data and then using algorithms to recognize patterns, objects, and even emotions. Now let's bring this concept to life with a use case. Picture this. You're at a reunion and you snap a group photo. Later, you decide to upload it to your favorite social media platform. Almost instantly, the platform suggests tags for each person in the photo. It's recognizing faces, distinguishing between different individuals, and even linking them to their profiles, all in a matter of seconds. That's computer vision in action. It's not just identifying shapes and colors, but understanding the context, recognizing familiar patterns, and making informed decisions based on that understanding. It's like your device is seeing and recognizing your friends just as you do. Diving deeper into the mechanics of computer vision, it's a multi-step process. First, the system captures visual data, which can be anything from a static image to a video stream. This data is then broken down into features. Think of these as unique identifiers or characteristics of the visual content. These features could be edges, textures, colors, or any other distinctive elements. Once these features are extracted, algorithms come into play. These algorithms, often powered by deep learning models, sift through the features to recognize patterns or objects. The more data the system is trained on, the better it becomes at making accurate identifications. Let's go back to our childhood days. Remember when you were learning about shapes? Initially, you might have been shown several pictures of a circle, and over time, you began to recognize that a continuous round edge signifies a circle. Similarly, computer vision systems are exposed to vast amounts of visual data. For instance, to recognize a cat, the system might be trained using thousands of cat images. Over time, just like you with shapes, the system learns to identify a cat by recognizing common features such as pointy ears, whiskers, or a tail. It's a continuous learning journey, refining its understanding with each new image it processes. Taking a brief pause from our exploration of computer vision, I'd like to extend a heartfelt thank you to our episode sponsor, the AI Novice Newsletter. Whether you're a seasoned AI enthusiast or just starting your journey, this newsletter offers insightful articles, latest trends, and deep dives into the world of artificial intelligence. It's like having a weekly AI digest delivered straight to your inbox. So if you're looking to stay updated and expand your horizons, make sure to subscribe. You'll find the link right in our show notes. And now, back to our topic. Now that we've touched on the basics of computer vision, let's dive into its real-world applications. It's truly remarkable how this technology is shaping the future in various sectors. Whether it's unlocking your phone with facial recognition, scanning barcodes at a store, or even analyzing medical images for early disease detection, computer vision is at the heart of these innovations. Let's take a moment to visualize a bustling city street. Amidst the sea of vehicles, imagine a self-driving car smoothly navigating its way. It stops for pedestrians, maneuvers around obstacles, and obeys traffic signals. How does it do all this? Through computer vision. The car's cameras capture the surroundings, and the onboard systems interpret this visual data in real time. It can identify a child chasing a ball, differentiate between a stop sign and a yield sign, and even detect if the road is wet or dry. This intricate dance of observation, interpretation, and decision-making is all thanks to the wonders of computer vision. As promising as computer vision is, it's essential to understand its limitations. Just like any other technology, it's not perfect. Factors like shadows, reflections, or even objects blocking the view can throw off a computer vision system. Additionally, training these systems requires vast amounts of data, and any bias in this data can lead to skewed results. Picture yourself walking in a dimly lit alley at dusk. Even with our sophisticated human eyes, recognizing a friend from a distance might be challenging. Similarly, a security camera using computer vision might struggle to identify a person accurately in such low-light conditions. Another example could be when you're trying to take a photo through a glass window, and there's a reflection. While our brains can easily differentiate between the reflection and the actual scene, a machine might find this more challenging. The advancements in computer vision are not just technical jargon for scientists and engineers. They have real-world implications for all of us. As this technology becomes more embedded in our daily routines, it will redefine how we interact with the digital world, making many tasks more intuitive and personalized. Let's fast forward a bit. Imagine a Saturday afternoon, and you're planning to buy a new outfit for an upcoming event. Instead of physically going to multiple stores, you decide to shop virtually from the comfort of your home. Using computer vision, you can try on different outfits. The system scans your body, understands your dimensions, and overlays the clothes on your digital avatar. You can see how a dress or a suit looks on you, how it fits, and even match it with accessories. This seamless integration of the digital and physical worlds is what the future of computer vision promises. It's not just about machines seeing, it's about them understanding and enhancing our experiences. As we dim the lights on our exploration of computer vision, let me paint a picture for you. Imagine a world, not too far from now, where a child born with visual impairments is given a pair of smart glasses. These glasses, powered by advanced computer vision, narrate the world to her. She sees the vibrant colors of a sunset, the intricate patterns on a butterfly's wings, and the twinkling stars in the night sky, all through the descriptions provided by her glasses. Now consider this. As this child grows, she develops a unique blend of human experience and machine interpretation. Her perception of the world is a symphony of human emotion and machine precision, not just because of her visual impairment, but because of the fusion of human and machine vision. This is the potential of computer vision. It's not just about machines seeing the world. It's about enhancing and transforming human experiences. As we stand on the cusp of this new era, one has to wonder, how will our stories change when the storytellers are not just us, but also the machines that see alongside us? Thank you for joining me on this journey into the world of computer vision. If this episode sparked your curiosity, don't forget to subscribe and share the AI Novice podcast. And always remember, the horizon of the future is shaped by the questions we ask today. Until next time, fuel your wonder and chart the unknown.